Okay, hi everyone. So we're sticking with sequences again today. Moving on from quadratic ones, we're moving on to just sort of the last couple of types of sequences that we need to get through. So done. We're just going to start off with a recap with what we've done so far. So types of sequences we looked at so far. We looked first at the linear ones. You'll sometimes see these called arithmetic as well. I think it's they're about 50-50 which one they get called. So linear / arithmetic. And with this type of sequence, the change between each term is the same each time. So each time it's changing by the same amount. So you don't need to work out the second difference, you can just work out the first difference for these ones. So an example of that would be 3, 7, 11, 15, because each time this is changing by 4. So this one is an arithmetic sequence. And the nth term of this is in the form an plus b, so something n plus something or minus something. So it'll be, in this case, we look at the difference and that tells us what number goes in front of the n, so it'd be 4n. And then to work out the plus whatever, we need to work out the 0th term, so in this case it'd be minus 1. So we'd have 4n minus 1, and that would be our nth term for this one, so something n plus something, and in this case it's plus minus 1. The second type of sequence we looked at was quadratic. So this one, it doesn't change by the same amount each time, but the second difference is the same each time. So it's the second difference that we use to work out the coefficient of n squared. So in this one, the nth term is of the form an squared plus bn plus c, and we need to use the 4-step method that we've done in the past couple of lessons. So work out the second difference, and then when we've worked out the second difference, we halve that, and that is the coefficient of n squared, so that gives us a. And then from there we work out the difference, which tells us the bn plus c. And the difference will sometimes just be a number, or it'll sometimes be a sequence in itself that we then have to work out the nth term of. So those are the two we've looked at so far. So today we're going to look at another few sorts. So this is the first one we need to, sort of the new one. This is cubics. We don't really need to be able to do anything with these, and we don't really need to be able to work out the nth term for them. But we do need to be able to recognise a sequence of cubic numbers. So a cubic number is similar to a square, it's just times by itself another time. So the first one, this is 1 cubed, 1 times 1 times 1. Second term, 2 cubed, 2 times 2 times 2. So then we've got 3 cubed, 4 cubed, 5 cubed. Don't really need to be able to do anything with this. We might be asked to carry on the sequence, in which case we'd also have to work out 6 cubed and 7 cubed. But in general, don't need to be able to do as much with this. It's not as bad as the quadratic ones because we just don't need to be able to do as much with it. But we do need to be able to recognise a sequence of cubic numbers. So what I would say is, if you're given a sequence, if you look at the difference between them and it doesn't stay the same, that tells us it's not linear. If the second difference doesn't stay the same, it'd be worth looking to see if it's a cubic, because it could be. Okay, so what we need to do now, we've got some notation to look at, and we've actually seen this question before, but the focus was a little bit different. So we've got our n, so this tells us where in the sequence it is. And we've got our sequence here, 2, 5, 8, 11, 14. And so we can see that the difference between them is 3 each time. So this is a linear sequence. So we're happy with that. But the new bit of notation is this bit here. U and then a lower, sort of a small n. So u n subscript n. And what this means, this is just basically another way of writing the nth term in the sequence. So if we were looking at u1, that would be the first term in the sequence, u1. The second term in the sequence would be u2. Third term would be u3, u4, and u5. So basically it's just, the u is just a letter, the number tells us that it's that position in the sequence. So what we've got over here, un, that is the nth term in the sequence. So what we could write for this, when we work out the nth term, you could write it as un equals 3n minus 1 for the sequence, because the nth term is 3n minus 1. So rather than writing nth term, we could write un instead. So it's just a slightly different notation. So it's a similar kind of idea, just slightly different notation. So we've looked now at the position to term formula. So this top bit here. What that means is that's telling us it's a formula that tells us what the term in the sequence is by what position in the sequence it is. So that's something like this. So we've got the nth term is 3n minus 2. So we've got a formula that relates the position in the sequence n to what the term in the sequence would be. So this is telling us, right, so if we're in position 3 in the sequence, this is what u3 is, and it tells us the answer. So this is the kind of thing we've seen before, this position to term formula, and that is telling us what the term in the sequence is from its position. What we've not looked at yet is the term to term formula, and what this tells us is how to get to a term from the previous term. So the way we would write that is, so we'd write un equals, so it's telling us the nth term of this. So how would we get, so let's say we're going from the third term to the fourth term, what do we need to do to get there? If we're going from the fourth term to the fifth term, what do we need to do? So each time we're adding 3. So what we would say for this one notation wise is un equals un minus 1, so the term before the nth term, plus 3. So what that tells us is for any term in the sequence, to get to it from the previous one, you take the previous one and you add 3. So it's a similar idea. The only difference is we're doing it from term to term. So rather than going from a position in the sequence, this is just relating the terms to the next term in the sequence. So term to term formula, you can sometimes get given one like this where you're told the term to term formula. You would then have to either write out the sequence or work out the nth term from that. So what I would generally do is, if I was given a term to term rule, I'd write out the sequence and then work out the nth term for that. Okay, so this is partly why I've been looking at that new notation, Fibonacci style sequences. So Fibonacci was a mathematician who came up with sequences of this sort. So I want you to have a look at this sequence. I think this was in the starter last week. See if you can work out what the pattern is with this one. What is linking the numbers in this sequence? So if you want to pause it, have a think about that just before I go through it. Feel free to pause it now. Okay, so with this one, what we're doing to get to each term in the sequence is we're adding up the previous 2 terms. So obviously these two, they're starting the sequence, there isn't 2 terms before them, so it doesn't really apply to them. And with Fibonacci style sequences, you'll sometimes get different variations on what the starting 2 numbers are. But from then, the rule is the same. With this, we're adding up the 2 terms in front of it. So to get 2, we're adding 1 and 1, and that gives us 2. To get to 3, we're adding the 2 terms before it. So we're doing 1, add 2 gives us 3. To get 5, we're adding the 2 terms before it, so that's 2 and 3. So that gives us 5. To get to 8, we're adding the 2 terms before it. So basically, each term, we're adding the previous 2 terms. So if you want a bit of a challenge, I want you to write out now, using term to term notation, how you think we would write the nth term of this. So it's not going to be a rule for a position to term. What I want you to have a go at is writing out the term to term rule. Okay, so we've got un, so the nth term of the sequence. To get to that, so let's say we're looking for 8. We'll say we're looking for u 1, 2, 3, 4, 5, 6. So u6, we work that out by doing u5 add u4. So if we were doing un, what we add is un minus 1 add un minus 2. So what that's saying, for any position in the sequence, we get to it by adding up the two terms before it. So the nth term in the sequence is we add the n minus 1 and the n minus 2 term. So we've got our term to term rule for it. So each term, so we've got it written out a bit neater there. So the nth term for this, and make sure you learn this, it's really important. Just kidding, you don't need to learn this. So the nth term of this is this horrible formula, but you can actually check it. If you want to have a go at a couple on your calculator, you can feel free, sub in some numbers, check that it comes out with the right answers. But you don't need to know this, so don't learn this. Obviously you can do if you want to, but you don't need to. You do, however, need to be able to write it in this form, but you don't need to know the nth term from position. Okay. So, last type of sequence we're going to look at today is geometric sequences. So, what this means is basically it's adding on something each time. It's something a little bit different. So, just have a quick look now. We've got a sequence here. So 4, 8, 16, 32, 64. See if you can spot what the rule is. So just pause it if you want to have a look. Okay, so it's not adding on the same thing each time. What we're doing is we're doubling it each time. Times 2, times 2, times 2, times 2. So we're doubling it each time. And this is called a geometric sequence. And in geometric sequence, to get from term to term, we multiply or divide by the same thing each time. So in this case, we're timesing by 2 each time. And with these, again, it's similar to cubic. We don't need to be able to do that much with them, but we do need to be able to carry on the terms, and we do need to be able to sort of work out what the pattern is and recognise them. So those are the key things we need to be able to do with geometric. At this point we don't need to know the nth term. However, I am going to go through just now how we would work out the nth term. So if you want to stick around for this next bit, feel free. If you don't, skip ahead to the one after this bit. So you don't need to stick around, but I am going to go through how we work out the nth term. So if we've got 4, 8, 16, 32, 64. So we're timesing by 2 each time. So we're timesing by 2 each time. And what we want to do is work out a system of writing this out as a position to term rule. So if we've got 4, 8, 16, 32, what we've really got, we're going to write it in a slightly different way. We're going to write 4 times 2, 4 times 2 times 2. So each time we're timesing by 2. One more, so 4 times 2 times 2 times 2 times 2. So this looks a bit weird, but we'll see why we're doing this now. So what we're going to do now, where we've got 2 times 2, 2 times 2 times 2, 2 times 2 times 2 times 2 times 2. What we're going to do is we're going to write that in a slightly different way. So we're going to write it with powers. So we've got 4 times 2, then we've got 4 times 2 squared, 4 times 2 cubed, 4 times 2 to the 4. Okay, so what we've got here, we can see that the power of 2 is always, so look at the position. So this is position 1. This is position 2. I'll just write it as 2 to the power of 1. 3, position 4, position 5. So I want you now, look at the position in the sequence, and then look at the power of 2 that it's got with it. So remember for this first one, 2 to the power of 0, that is 1. So we could also write this as 4 times 2 to the 0 if you wanted. So what's the connection between the position and the power of 2? So the connection is that the power of 2 is always 1 less than the position. So it's 1 less than n. So our system, our nth term for this one is 4 times 2 to the power of n minus 1. So you don't need to be able to do this at this point, but if you can do, that's great, and you'll find it much easier next year. So, nth term, we've got our sort of starting number 4, and it's times by whatever our multiplier was. In this case, it's 2 to the power of n minus 1. And if you want to have another go at a geometric sequence, see if you can work out the nth term. Those, I think some on Corbett Maths if you want to have a practice with them. If you want to do the extra work and sort of get ahead for next year. Okay, so the main thing we need to be able to do with geometric sequences is be able to recognise what the multiplier is and carry them on. So, with this case, we need to work out what are we multiplying or dividing by each time when we go from term to term. So getting from 2 to 6, we're times them by 3, 6 to 18, times by 3, times by 3, times by 3. So a really common question is give the next term. So that is what we will do. So giving the next term to the sequence, we need to see what do we need to do for a geometric sequence to get from one term to the next. We're going to times it by 3. So we need to do 162 times 3, which gives 486, I think. So times in by 3 each time, we've worked out the next term in the sequence. So again, I'm going to show how to do the nth term for this one. So again, if you're interested, feel free to stick around. If you want to pause it and have a go at working it out yourself, also great, feel free to do that. If you want to do that, pause the video now, and then I will go through how you do that. Okay, so we're starting with 2, and we know our multiplier is 3, so our next term is 2 times 3. Next term after that, 2 times 3 times 3, 2 times 3 times 3 times 3, and so on. So we've got 2 times 3 to the 1, 2 times 3 to the 2, 2 times 3 to the 3. And this is position 1, 2, 3, 4. So similar to the last one that we did, we've got our relationship between the position in the sequence 2 and the power 1. So the power of 3 is always 1 less than the position in the sequence. So our nth term un would be 2 times 3 to the n minus 1. And that would be our nth term for the sequence, so that is what it's asking down here. Okay, so one last one just to practice before you go away and have a go at the exercise. So on this one, I want you to pause the video now, have a go at working out what term comes next in the sequence. So it's spotting what the pattern is. So these are geometric sequences. So have a go at working out what comes next. So pause the video, have a go at that now. And I'll go through it in a second. Okay, so this top one, each time it is timesing by 10. So the one after this will just be times by 10. So 3, and then it'll be 5 zeros. So we've worked out our next term. Really common question. This one, multiplier is 5. So our next term will be 2,500. And if you want the nth term for this, it would be 30 times 10 to the n minus 1. And this one would be 4 times 5 to the n minus 1. So we've got our nth terms, we've got our rules. So what I want you to do now, go have a go at the worksheet on Firefly. If you need to revisit anything from the slides, just come back and have a look at the section of the video that's useful. Okay, good stuff.